Hello, dear students. Today we will solve one more problem. This problem is basically from Current Electricity 2025 ICSE Board Class 10th problem. The problem is like this. Three identical bulbs B1, B2 and B3, each of power rating 18 watt 12 volt are connected to a battery of 12 volt. You have to calculate the resistance of each bulb, and in second part you have to calculate the current drawn from the cell, and in B part, if the bulb B3 is removed from the circuit, then will the brightness of the bulb B1 increase, decrease, or remains the same? So this problem is very simple. We'll proceed for the solution. So students, in first part you have to calculate the resistance of each bulb. And students, we know there is one relationship between electrical power, voltage, and current, and it is P is equal to P into I. And students, from Ohm's law, we know that voltage is equal to current into resistance. So students, here in the formula of power, we will replace current I from here to here. P will become V square by, here we have replaced I from this V is equal to IR. From here I will be equal to V upon R, and here if we will put I is equal to V upon R, then your power will become P is equal to V square by R. And students, power and voltage are given, so we can calculate easily the resistance through each bulb. So here R will become V square by P, and students, voltage is given 12 volt. So here 12 into 12 upon power. Power is given 18 watt. So students, it will become 144 upon 18, and it will become 8 ohm. So resistance through each bulb here is 8 ohm. So this was part A, and the answer is resistance through each bulb is 8 ohm. Students, in B part, we have to calculate the current drawn from the cell, and from Ohm's law, we know that V is equal to IR and I is equal to V by R. And students, here we know the voltage, and if we will be able to calculate the equivalent resistance of this circuit, then we can calculate the current drawn from the cell. And students, if you will see the circuit carefully here, B2 and B3 are in parallel combination, and the parallel combination of B2 and B3 is in series with B1. So here first we will calculate the parallel combination of B2 and B3. So students, resistance through each bulb is 8 ohm, and here B2 is parallel with B3. So students, we will first calculate the equivalent resistance of B2 and B3, that is in parallel combination. It will become 8 into 8 upon 8 plus 8. So here it will become 64 upon 16, and it will become 4 ohm. So here we have calculated the equivalence of B2 and B3. And students, here B1 is in series with equivalent parallel combination of B2 and B3. So here resistance through bulb B1 is 8 ohm, and here we are calculating equivalent resistance. I'm just denoting it by RS. So here it will become 8 plus 4, it will become 12 ohm. So the equivalent resistance of this circuit is 12 ohm. And students, as we all know, I is equal to V by R. V is 12 volt and resistance is 12 ohm. So here it will become 1 ampere. So the current drawn from the cell is 1 ampere. So this was part second. Current is 1 ampere. And students, in B part, if the bulb B3 is removed from the circuit, then will the brightness of bulb B1 increase, decrease, or remains the same? So students, if here this bulb B3 is removed, so here no bulb B3. So students, if bulb B3 is removed, then we are left with only bulb B1 and B2. And if you will see the circuit carefully, here B1 and B2 are in series combination. And students, if we will calculate here the equivalent resistance of the circuit, it will come out to be here B1 and B2 are in series. So in series combination, we just add the resistances. So here 8 plus 8 is equal to 16 ohm. So here resistance has increased from before. Before, when bulb B3 was also in the circuits, the equivalent resistance of the circuit was 12 ohm. But here, if we have removed the bulb B3, here equivalent resistance is coming 16 ohm. So here resistance has increased. So students, if resistance increases, then current decreases. And students, if current decreases, then if you will see the power, P is equal to V into I, and here if we will put P, V is equal to IR, here it will become P is equal to I square R. So students, here the brightness of a bulb depends on the power it dissipates, and if current decreases, then power also decreases. Here power, just here it will depend on I square of current. So if current will decrease, then power will also decrease. And if power will decrease, then brightness decreases. Brightness. So this was the solution of this problem. And students, you have to be just careful with the equivalent resistance in series and parallel combination. Students, if we have resistance in series, so we just add. And if we have resistance in parallel, suppose that we have two resistance, then we take equivalent resistance is equal to 1 upon R1 plus 1 upon R2. Same way. And here RS becomes R1 into R2 upon R1 plus R2. So we have to just take care of this series and parallel combination. This is very important. Several questions have been asked in your board examination from this. So if you like my problem solving technique, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.